Okay. The focus of the previous lectures has been one to tell you that there is a very definite systematic process which we are interested in following in this course. We call that process as engineering design process. The first step in that process was to identify the requirements. Drafting a PDS, the product design specification, was the first step. That is to know what to do. Next, we said one of the other important idea in this course is to actually generate as many ideas as possible, for which we in the previous lecture discussed about creativity and stuff like that, to emphasize on the fact that by using creativity you should invent as many diverse solutions as possible. Divergent thinking, we said. Now the very crucial step in this whole process, that is a convergent thinking process. Once there are various concepts generated on how to solve a problem, we have to select one concept as the optimal solution. Recall our previous discussion wherein I claimed that one solution is no solution. If you say there is a problem, this is how I am going to solve it, no, that's not engineering design. Here you are highly encouraged to give as many solutions as possible in the beginning. Then select one solution among them using some criteria. So today's lecture I will devote to the topic of how to finalize, how to find that optimal solution, or more formally this is called as concept selection in engineering design. How to identify the optimal solution. There are basically 2 to 3 methods. I will elaborate on all the methods, and I expect that you follow any one of the method in your actual working. Let us begin some with basics. Let us consider any selection process. For example, in our earlier PDS discussion, I think we were interested in developing a PDS for a coffee cup or something like that. Whatever it be. When you are spoiled for choices, when you have to select one among competing choices, how would you choose one? There are many things from which you have to choose one. How will you choose that? Intuition, gut choice, gut decision, whatever you want to call it. Intuitive decision making. Throwing a dice, tossing a coin. How? Is there a very logical thought process that we follow to select something? No. Then randomly choose something. How do we choose? Given something, for example, say we go to a ice cream shop and want to select one. How? You like something. How do you like something? Oh, we are getting into very complex things, forget it. In many places logic does not work. But we are speaking purely about logical choices. You are all kids, I can't talk some mature issues with you. Idea is simply this, that we need a very logical process of decision making in engineering, because we can't rely on intuition. Engineering decision is a very serious profession. For example, if you want to build a bridge, if there are 5 choices of building a bridge, I can't say I am selecting this because I like that. Intuition has no role to play in engineering design, nor does that thing called as common sense. Because any profession for that matter, and engineering specifically, is about making informed choices. You have to make that choice. What is engineering all about? Engineering is making that judgment on what solution to pick and what not. That is engineering. That is the job of any professional. When there is a solution space, when there are more than one solution, you should know how to pick a solution. That systematic process is what we are interested in. Why do we need that? We need that mainly because any decision that we take in our professional lives, we have to defend it later. As I keep saying, my favorite slogan in my classes is that there is nothing in this world called as good and bad decisions. There is no good decision, there is no bad decision. There are only defendable decisions and non-defendable decisions. If you can defend your choice on why you have done that, you will survive in the profession. If you can't defend, it may be good, it may be bad, that's immaterial for us. A building collapses. The engineering design may be very good. That does not matter. Can you defend why the pillar strength was that much, the beam strength was that much? Can you defend it? You will be saved, otherwise you will be behind bars. Professional judgment should be justified. That is why we need a formal process. Otherwise we don't need to discuss all this. Any selection, randomly you can select something and go and develop it. Okay? So what I am trying to tell you is, I am justifying the need for a process to select a concept. When there are many competing concepts, you need a process to select it. That is my starting point. What are the different ways? Let us see. I'll start with one simple technique. Everyone who has followed it, we call it intuition, but we have not thought about the whole process. Idea is very simple. Okay, what was our problem? Coffee mug. Say we were interested in developing a coffee mug. We wrote a very detailed PDS, and now we know what the coffee cup should do, and using all the creativity that we have come up with 4 or 5 concepts of how to build a coffee cup. We represent the concepts using some small graphical notation. Say, I am not a very great artist, otherwise I would be M.F. Hussain. Small ideas. Say I have developed 4 or 5 concepts, how much ever I can write. ಇದೊಂದು ಕಾನ್ಸೆಪ್ಟ್. ಮಗ್ ಅಂದ್ಕೊಳ್ಬೇಕು, ಕಾಣಿಸಿಲ್ಲ ಅಂದ್ರೂ ಅಂದ್ಕೋಬೇಕು. ಮಗ್. I am a software engineer, I don't need to write anything on paper. This is my favorite earthen ಮಣ್ಣಿಂದು. The thing I hate very much, Chinese cup. And this is our own filter coffee. Filter, steel cup. Okay. If I try more, I can become an artist. Something. So I have come up with different concepts. Okay, I have to select one for production. How do I select? Intuition is ruled out. Throwing up a dice is, exactly. So basically the point is very simple. We'll have a set point, criteria, based on which we will evaluate everything. We do it every time, right? We have a set of criteria. We know that the solution should be having this quality. When you go to buy a jeans, I know that the jeans which I am going to buy should have this quality. I look for that. That means criteria will be there. Criteria. Whatever may be the criteria. For example, ease of production, ease to use, economical, whatever may be the criteria. I will identify the criteria. 1, 2, 3, 4, etc. Right? Then what do? We see whether this concept, whether this satisfies this criteria, this criteria, this criteria, this, correct? This you will find it in all bike advertisements or refrigerators or something, TV, plasma TV, comparison. Onida, if the advertisement is by Onida, everything will be right, everything else will be wrong. Correct? Everybody understands this. This is the basic idea of concept selection. So what do? You identify the concepts, you identify your criteria, then check against each criteria. Whoever scores more will be the winner. Simple? Yeah. Simple solutions will always be stupid solutions in engineering. What is the basic problem with this? What is the basic problem with this method? Exactly. So, all requirements we have considered it as equal. This may be more than this. This requirement, for example, is to manufacture. For me as a new company is more important than anything else. It is not weight. So the criteria is not weight. That is the problem. So this is the method. Basic method. How to improve this method? There are two things. One, as the gentleman said, we have to weigh the criteria. We have to rank the criteria in some order. How to do that? There is one basic method, matrix method. What you should do is take each, okay, I'll write it here. I want to use the board space in a more better fashion. I'll write it here only. All criterias are ranked. How to rank? There is a method. Let me tell you that method. Take the criterias. We have identified 5. Take 5. Okay? And write the criterias here on the other side also. This is a binary matrix method. So this will have no entry. 2, 2, 3, 3, 4, 4, 5, 5 will have no entry. Take this criteria number 1, and compare with other criterias. Take one criteria from the, what is this, vertical axis, and compare it with horizontal axis. If you think this is more important than this, write 1. Okay? Compare 1 and 3, which is more important? If 1 is more important, write 0. If 3 is more important, write 1. What the point? So it may look something like this. This is binary. So what should 2, 1 be? Correct? Got the point? So like this you fill everything. Then you will have the total marks scored by each criteria. Right? It may look something like this. Now whoever has more marks means that is a highest priority requirement. Did you get this method? There is a very easy, of course anybody knowing the basic mathematics will tell how to check whether you are written this in a correct way or not. Okay, this is one simple mathematics. Count everything, you will get this x, right? You will get the x. This x should be equal to n into n minus 1 into 0.5, where n is a number of criteria. 1, 0, madhya ishtu, half, that's all. You are finding the total weight of the matrix. Okay? So what we have done, we have started with a simple idea to take the criteria and the concept and to see whether each criteria matches each concept. Then we said some criteria may be more important, so we are ranking. Now what you can do, you can come back here and actually see which criteria is more important, whether that is satisfied or not, and then take the decision. That is one way. There is one more way of doing this. That is, instead of directly transposing the values to this, there is one more way, that is called weighted matrix, weighted criteria. I'll just explain that. One method is ranking the criteria. Once you rank the criteria and come back to this diagram, do the same exercise, you will know which concept to select. That is one way. Second way is, again refine whatever you have done using the criteria ranking to some more sophisticated method. That is, what will happen usually is that, for example, let me very practically tell you. Let us take two concepts, okay? Take only two concepts. This is how the chart will look. By some combination, you will count. You will give the rank. Okay, give the rank. This is most important, this is least important. So, most important will get 10 marks. This is 0. Some category. What may happen is, the total marks here and the total marks here may come same. There is always a chance. Though the priorities, weights are different, there is a chance that they may come equal. Then what to do is a question. Therefore, one of the idea always proposed is to give weightage to each requirement, criteria. Instead of simply ranking them, give weightage. Weightage andre out of 1. Out of 1, how much weightage is this, how much weightage is this, how much weightage is this. Instead of ranking, we are using weightage. How to do that? Well, it works like this. If there are 5 requirements, totally 5 requirements, group the requirements into subgroups. Group the requirements. For example, it starts from the root. The whole set of criteria can be divided, say, into 2-3 criteria. Criteria number 4 and criteria number 3. Criteria number 1 and 2 are combined under criteria number 3. Let me explain. For example, the cost of the product. The cost of the product is nothing but sub-part of the ability to manufacture, the ease of manufacturing and availability of raw materials. Availability of raw materials, if you have to source it from a long distance, the price will increase. If the manufacturing process is new, the price will increase. That is how you have to classify the criteria. Whatever you have identified the criteria, you should group them logically. Then you know that final value should be 1.0, right? Final value should be 1.0. Among this and this, which do you think is more and how much will you weight? For example, I will say that this is 0.7 and this is 0.3. Now these two should be summing up to 0.7. I should distribute evenly. So I will say this is 0.5, this is 0.2. So I am weighing the criteria. Instead of ranking the criteria, I am weighing the criteria. Then come back here, you can do the same exercise, you will know which one to choose. That's better technique. Right? So, we have seen one basic technique and then improving the technique using two methods. What are they? Criteria ranking and criteria weighing technique. Fine? Okay. The next method, the second method, which is a very famous method given by Pug.
Some of the models must be having some other disadvantages other than the listed requirements. That may be reducing the weightage of the selection criteria. So how do you reduce that?
You mean to say the design choices which will hamper the selection of a criteria? That is, this you should not. You can give negative weights. Here we are giving positive weights, start giving negative weights. So that will be decremented from your total count. Just like negative marking in your exams. Correct answer plus 5, negative answer minus 2.5. Find the total in your whole paper, you will know the value. Similarly, you can do here.
So it's a relative weightage. You mean relative?
Exactly. It is relative.
Very much different than the ranking.
It gives you more, no, it gives you more distinct values than the ranking method. Because you are using points, 0.7, 0.3, the difference will be there than using whole numbers. Okay, fine. Next, I'll come to one more method which was initially developed by Pug, now followed in most of the engineering design concept selection process. It's called Datum Method. Datum, D-A-T-U-M, Datum Method. Same thing, I'll transpose it there without my great artwork. I've done it once, more than sufficient. 1, 2 anta itko. Same thing, concept, process, criteria. Everything is same. How to use one more method. 4 concepts are developed, there are 5 criteria. In the datum method, there are 2 ways. I'll explain both the ways. Whichever is simple, you can follow it. Basic method is, first consider any one concept as the reference. The referred concept is called as datum. So you write datum in this column. That is datum. Datum andre the reference value anta artha, reference concept. Now take this concept. In this concept, take this criteria. Whether this criteria in this concept, is it better than this, or is as same as that, or is worse than that? There are 3 choices. This criteria in this concept, is it better than this concept, same as the concept, or is bad, worse than this concept? This is a reference point. If it is same, you are writing yes. If it is better, you are writing plus. If it is bad, you are writing minus. So this concept, this criteria compared to this is better, so plus. Okay? Similarly here, same, minus, something like this randomly we'll write. Fine? Do that for this. This concept, this criteria compared to this, how is it? Is it better, same, minus? So like this we'll say. We'll complete this. Whatever, I am randomly writing something. And finally, now you can see which is better. More plus means that is better. Correct? If 2 has more plus, then you have to see which one have more yes. That you can find out. This is one method. But many people say that you should not stop here. You should not stop in one iteration. What you should do, you should continue this process at least 3 times. Once you do like this, next what you do is, whichever has the highest value, say in our case this has the highest value because this has 1, 2, 3 plus. This is the highest value. Take this as datum. And continue the process. Then find out which is the highest. Take that as datum and again do this process. Which wins in 3 rounds, that is the ultimate design choice. People suggest that at least 3 iterations are must, because first time you are considering that this is the ideal solution. It may not be, right? So on 3 rounds, if you continue like this, probably you will get a better solution. Is this understood? Very simple. Datum method. The final method which I will discuss is called EVAD method, design evaluation method. EVAD, this is datum. EVAD, design evaluation. Design evaluation. The idea in design evaluation is quite different from this. Of course, we start with same. See, have you noted one thing? For example, come back to this original idea. Actually, take this as selection of genes or something like that. There were 3-4 competitors and you have identified the criteria. Easy to wear, color, price and things like that. Instead of writing yes or no, you would also do one more thing. You may say, for example, criteria number 1, easy to wear. You may say good, excellent, poor. Right? Color, good, not so good, okay. Price, economical, costly, cheap, something like that. That means while we are making a normal criteria listing, we always quantify it. It's not always binary. It's not yes or no. Every criteria will have a range which we have not considered anywhere. So in design evaluation, what we actually do is we evaluate each criteria in all possible dimensions. Okay, this method is used in many of the feedback techniques. Have you given feedback of teachers in first semester? How was it? 0, 1, 2, 3, 4, 5. Very poor to very good. If you don't make any entry, no, it will be average in all the cases. So if you simply log in and log out, the teacher will get a mid value, 50% marks. That has been written into software. Okay, but anyway, we will not discuss that. It's a bug in the software. So the same thing how we do it in EVAD method. The first thing what you should do is, for every criteria, you should identify minimum 4 choices. Minimum 4, excellent, good, average, bad conditions for every criteria. EVAD method alli, the notation used is plus for excellent, plus for good, minus for average, minus for bad. Okay? So here also plus minus plus minus. Now see, concept number 1, criteria number 1, is it good, is it excellent, average, poor. Okay, I'll say it is good. Criteria number 2 in concept 1, is it excellent, good, average, poor. Got? So which is that I have to choose? 2. I wrote it like that. That is more on the positive side than on the negative side, right? So if you see, we are quantifying everything. So if you look at all the 3 techniques at one, you will know how we have developed the solution. Again I will repeat. See, this does not happen in one day. And let me warn one more thing. Concept selection at the end of the day is more of a personal judgment. Again we follow all this method, correct? But this is again very subjective. what you feel, good to bad. So subjective. There is no proper weightage. All evaluation techniques at the end of the day are very, very subjective. Measuring ideas is not like measuring temperature. It cannot be perfect like that. It's very, very subjective, very much personal, very judgmental. Okay? But if you have any one of these sheets, if you do the brainstorming with your teammates, come up with a concept, tomorrow if somebody asks, you can defend. If somebody asks, why have you taken this decision? You can say, it's because I followed this method, I decided on this. Basically to defend yourself. Right? So what have we done? Prerequisite for concept selection is this. Your PDS should be ready. You should write the PDS as complete as possible. Second, you should have more than one concept. One concept idre enu madaka. You should have more than one concept. Basic idea is this. That is direct matching of criteria with the concepts. That is not good. Therefore, we improve it by ranking the criteria and by weighing the criteria. Next, we come to datum method. In the datum method, we compare one concept directly with the other concept. Finally, having a kind of a tournament to decide the winner. Round robin tournament. Then we come to evad method, wherein you quantify each criteria and finally decide on which concept to choose from. In the last segment of my talk, let me spend few minutes telling you actually what we do in software. Do we use such methods? Rarely so. Rarely so. Then what do we do? In fact, Ken Hurst speaks very briefly about the use of computers in decision making. Let me elaborate on that concept because that is what we are here to study. In computers, there is this idea of a machine, of a system, which we call as decision support systems. Please meditate on the choice of words. It is not decision making system. It is decision support system. It helps you take decision. It will not take decision. What decision support system actually tries to do is to build mathematical models using which you can take decision. That is, given choices like this, it comes up with some kind of mathematical formulations using which you can take decisions. Some complex, some straightforward. Best tool which you may have used are spreadsheets. Spreadsheets, they are excellent decision making tools. If you have the sales data of a company for 5 months, I can use a spreadsheet, write a small macro function and decide what will happen in next 5 months. If I have sales data of previous 5 months, I can predict the data for next 5 months using some simple mathematical techniques. But can I base my decision on that is a question. For example, I'll have 5 months sales data. Next 5 month prediction may be increasing. So I may say, okay, produce more goods because my computer is saying that the sales will increase. Suddenly one more bomb may be dropped somewhere and sales may go down. Who is responsible? No one. But you will have a reason to defend your choice. Excel can do this. All your spreadsheet programs can do such analysis. We call it 3-4 types of analysis are there in computers. One is what if analysis. What if? Second is sensitivity analysis. In what if analysis, if there are two parameters, the month and the sales. Let me just explain. Take this data. Consider this as sales data. month versus sales. What if analysis in computers always tries to give you, what if the month is 10, what will be the sales? This kind of predictions. What if? Second kind of analysis is what we call a sensitivity analysis. Sensitivity analysis is, if month is 3rd, sales will be this. So how sensitive is month to sales? For example, this month we may have a festival, therefore the sales are more. How sensitive is one data to the other data we want to know. That is called a sensitivity analysis. Third is goal seeking analysis. Goal seeking analysis is, I want to make some sales X5. When will I reach it? In how many months? I want to know. That is goal seeking analysis. I have set the goal and want to know when I will reach there. Right? Next is slicing and dicing. That is, for example, if you have a sales data like this, X1 sales, break it up. X1 sales in region 1, how much sales has happened? In region 2, how much sales has happened? Region 3. Slice it, dice it, and then do some analysis. All these things are supported today. We call such systems as decision support systems. Rarely do we use such paper-based techniques. These are very preliminary techniques, but nevertheless for beginners like you, they are good starting points. But please understand that they do have their own limitations, and we have come so far in decision making process today. Right? So this by and large completes the one major theme in my course that started with discussing what is engineering design. We have seen that the initial processes. We learned that writing the PDS is the most primary thing, because that is the basis for my all the future processes. Using creativity to build concepts and to select a concept among the various concepts which are designed. Here ends one major theme. When we come back after internals, we will discuss the second theme of design.